at amides as a functional group, and amides are organic compounds with a C double bond O attached to a nitrogen. So you will see sometimes the functional group of amide is written as CONH2, where these two bonds attached to the nitrogen are hydrogen. But of course, you can also have an alkyl group, whether you have one or two alkyl group. And we also looked at the properties of amides. Physical properties are similar to amines, but in terms of basicity, very different from amine. Amines are basic, whereas amides are not. The reason is not because amides don't have lone pair. Amides do have lone pair, it's just that the lone pair is not available for the hydrogen ions, okay? Because the lone pair is being withdrawn by the electronegative oxygen. We've also looked at the formation of amides, basically acyl chloride reacting with ammonia or primary amine, secondary amine to form amides. So today we're going to look at the reaction of amides, also something that was mentioned earlier on. The first type of reaction is reduction. Reduction of amides, we will use lithium aluminium hydride. That is the only reducing agent that we can use for amides. We cannot use hydrogen with nickel catalyst because that's not strong enough of a reducing agent. So what it does is that the CO group in amides will be reduced to form an amine. So amides can be reduced to primary amines by reaction with lithium aluminium hydride in dry ether. So you do not use an aqueous lithium aluminium hydride, it's explosive. They can occur at room temperature, so no heating is required. The initial reaction is followed by treatment with dilute acid. And as mentioned just now, the C double bond O group is reduced to amine. Okay, so we're going to look at the first example, which is the reduction, or we're going to reduce ethanamide. Okay, so if you still remember, ethanamide is when you have two carbon, CH3, C double bond O, and H2. Okay, so reduction, lose or gain hydrogen. Reduction, gain. Gain hydrogen, and we gain 4 hydrogen. So to simplify the equation, we don't have to write down the lithium aluminium hydride formula, okay? So the H is our, I'll change the color so that you can see. It's a representation of a reducing agent. Okay, so that's our reducing agent. And then what happens? The learning objective just now says that the C double bond O, the amine, the NH2 group doesn't change. Okay, that's already saturated. That means it can no longer accept any more hydrogen, but the C double bond O is unsaturated. The double bond will break and you will lose the oxygen. That's what reduction is. You gain hydrogen, you lose oxygen. And of course, the oxygen that you lose is not just randomly lost as O. You produce water. Okay, so this works for any primary amide. In this case, we use ethanamide as our example, okay? So just highlight the C double bond O and notice that the NH2 group is unchanged. It stays unchanged. The next example, we are going to look at secondary amides. The reactions shouldn't be too different, okay? We are going to lose that oxygen on the C double bond O as well, and we will gain hydrogen. Are we ready to move on? Okay. Sorry. Before that, I will just mention this. Primary amide will be reduced to primary amine. Secondary amide will be reduced to secondary amine. And I've already mentioned to you, even though only 2 hydrogen is being added to the original amide molecule, the other 2 hydrogens, because you have 4 here, right? The other 2 hydrogens is being used to produce water. Okay, next is to reduce N-methyl ethanamide. Okay, so I didn't teach you the naming of amides, but let's try to draw the structure here. Ethanamide means there are 2 carbon. Okay, CH3, C double bond O, true carbon. N-methyl means that there is 1 methyl group attached to the nitrogen. So this is why the name is N-methyl. Okay, same thing. We want to reduce the amide. We need 4 hydrogens, and that's our representation of a reducing agent. We don't want to add lithium aluminum hydride in our equation, otherwise it would be a nightmare to balance. Can be done, but just not our concern. Okay, so the nitrogen part stays unchanged. The only thing that is changing is that you lose the oxygen from the C double bond O, and that carbon gains hydrogen. Okay, same thing. Secondary amide will form secondary amine. If you're wondering how do I know it's secondary, you look at the nitrogen. How many hydrogen does it have? There's only, well, how many alkyl group or acyl group it is attached to? There's 1 alkyl group, 1 acyl group. So in total, 2. It's secondary amide. Same thing for the amine. It's attached to a methyl group and an ethyl group. That makes it a secondary amine. And of course, the other product that I forgot to add is H2O. Same reagents, same condition. Okay, you don't need to heat them up. Okay, that's reduction. The next one is hydrolysis. Before we look at the reaction, what do you understand by hydrolysis? Apa hydrolysis? The breakdown? The breakdown of a bond, okay. So in the presence of water, yes. Amides is actually like an ester. Okay, so C double bond O, O, CH2, for example. Okay, so during the hydrolysis of ester, we are breaking the C single bond O. Yes, we get COOH, carboxylic acid, and we get an alcohol. Yeah, amides will undergo the same process as well. So when we break it down, it will form 2 things. Okay? If it was the reverse, how do we form amides? We use acyl chloride and amine. But the hydrolysis, we will not produce acyl chloride because where would we get the chloride from, right? So we will instead break it down or form COOH, and the other one, instead of forming alcohol, we will form amine. Okay, so it doesn't have to be, it can be primary, secondary, or tertiary amine. Okay, so I'll just leave it at that. That's the basic principle. Okay, so we're going to describe the reactions of amides. via the hydrolysis with aqueous alkali or aqueous acid. Okay? Right, so amides are slowly hydrolyzed by refluxing with aqueous alkali or acid. First, we're going to look at acid hydrolysis. The products will be carboxylic acid and ammonium salt. So just bear with me on that one first, ammonium salt, okay? The reagent, you can just use any dilute sulfuric acid or dilute hydrochloric acid. You don't need water because it's already a solution, an aqueous solution. The water is already in there, okay? Hydrolysis of ethanoids. Right, now I don't want you to copy this down first because I want to discuss the process. So ethanamide looks like this, okay? So the easiest one, I'm just going to play with primary amides, but this works with tertiary. All I'm doing is just changing what's attached to the nitrogen, okay? But since I'm using ethanamide, I'm just going to have two hydrogens on that nitrogen. So during hydrolysis, this bond will be broken because that was the bond formed when acyl chloride reacts with amine. So there are two things. Remember, this is an acid condition, okay? So don't copy it. There are two things. You will get the carboxylic acid part, yeah? And you will get the amine. So you just get the hydrogen, right? Now, you are in acidic condition. Will your acid react with the ethanoic acid? Will your acid react with ammonia in this case? It's ammonia, yes? So NH3 reacts with H plus to form NH4 plus. So that's why your products, if you look at your notes, it says that the products are carboxylic acid and ammonium salt, because whatever ammonia or whatever amine is produced here, it will react with the acid because it is an acidic condition. Okay, so this works if I just change this into CH3. So my ammonium ion will be NH with CH3 2, and it's still an ammonium ion. All right, how do I know if it's ammonium ion? Something is missing. NH 2. Okay, how do I know if it's an ammonium ion? When I have 4 bonds around the nitrogen with a positive charge, then that's my ammonium ion, quaternary amines. Okay, right, so let's tidy that up. And we'll write down the equation. The equation is that ethanamide plus H2O plus H plus, and then you heat it under reflux. You should produce ethanoic acid, CH3COOH. So I will highlight that, plus NH3 with H plus. Okay, so it's NH4 plus ammonium ion. So you can add a note. The ammonia or the amine produced will react with H plus in acidic condition. You see? Okay, so this works for any amides, really, primary, secondary, or tertiary amides. You will form the relevant carboxylic acid and also the relevant ammonium salt. Now, why do they say ammonium salt? Because in my equation, I have written it as H+. But if I use HCl, which is a hydrochloric acid, the ammonium ion will combine to become an ammonium chloride. That's the only difference, okay? So ammonium ion, when it has a counter anion, it will form a salt. Okay, next example, we're going to look at, that's the only example for the acid hydrolysis. Next one, we're going to look at alkaline hydrolysis, okay? Or a base hydrolysis. This time, the products will be carboxylate salt and ammonia. The reagents, first, you use aqueous sodium hydroxide, and then later on, you add H+. Okay, so we'll see why we do that. First, we will start with hydrolysis of ethanamide. Same thing. Ethanamide is when you have two carbon. Okay, again, we want to break that bond to form ethanoic acid. Yeah, C double bond O, OH, CH3. Okay, so we'll talk about this first, copy down later. And we get ammonia, NH3. All right, but remember, we are in a basic condition. What will the hydroxide ion react with? The acid or the ammonia? Acid, okay? So what happens when ethanoic acid reacts with a hydroxide? What do we form? Reacts with OH minus. What do we form? An acid, if it loses H plus, what does it become? Carboxylate. It's called the ethanoate. Okay, so it forms ethanoate ion. That's why you see here we form carboxylic salt and ammonia. Okay, so same thing. You actually have the acid first, but because we are in a basic condition, the carboxylic acid, whatever it may be, ethanoic, propanoic, butanoic, will react with the hydroxide ion to form a salt called carboxylate, okay, depending on what carboxylic acid you have, but it will always form a carboxylate ion. Okay, so let's tidy that up. So we will add sodium hydroxide, NaOH. So the Na is just the counter ion there. And then reflux. We should get CH3, C double bond O, O minus, and the counter ion is Na plus. The other product would be NH3. Okay, a little note there. Ethanoic acid produced will become ethanoate ion in basic condition. Okay, there's a second step. So this is step 1. The second step is the liberation of the acid. Okay, liberate means produce or release the acid. Okay, second step is liberation of acid. So if ethanoic acid is an acid, the ethanoate ion will be a conjugate base. Agree? Yeah? So this ethanoate acid, this ethanoate ion, a conjugate base, will react with acid. Okay? So if you want to produce acid from the sodium ethanoate, here, how do I make this molecule becomes an acid? It needs to gain a H+, right? So that's why it reacts with an acid. So the acid can be anything, HCl, H2SO4, HNO3. That's my second condition. You see here, the second part is the addition of the H+. So I cannot mix sodium hydroxide and hydrogen ion together. I let the sodium hydroxide react first. After I form the ethanoate, then only the ethanoate, I react it with acid, just any acid to give me the hydrogen ion to form CH3COO and that hydrogen. Then I form an ethanoic acid. Okay? So that's why it says the sodium carboxylate salt can then be acidified to liberate the carboxylic acid. Okay. At the bottom it says aqueous sodium hydroxide can be used to distinguish an amide from an ammonium salt. An amide will liberate NH3 when it is heated with aqueous sodium hydroxide. So you see here, ammonia is formed when an amide reacts with sodium hydroxide, but heated. Okay? Earlier on, let me try to find, it's still in the same topic. Ammonium is in the very first part of this reaction, I think, if I'm not mistaken. Here. Okay, so ammonium can also react with sodium hydroxide, but it reacts at room temperature. You don't have to heat it up. It will also produce ammonia. Okay, so because of this observation, you can use this reaction to determine, say you are asked to differentiate or distinguish between an ammonium and amide, you will use that reaction. Okay, try to add sodium hydroxide at room temperature. Is there a reaction or not? If there's a reaction, that means it's an ammonium salt. If there's no reaction at room temperature, then it must be an amide, because amide can only react with sodium hydroxide when it is being warmed or heated. Okay? Right, here is a summary of what we were just looking at. This works for a primary amide. It works for a secondary amide. Same thing, in acidic condition, you will hydrolyze the amides into a carboxylic acid and ammonium, okay, because it's in an acidic condition. Whereas in basic condition, you will form not a carboxylic acid, but a carboxylate salt. You probably will first form a carboxylic acid, but because it reacts with the hydroxide, it forms a carboxylate salt, and it will also release the original amine, whatever your amine was in the amide molecule. Okay? Okay, that's just the explanation. Right, so that is all for your theory today. We will take a break and then we'll discuss your paper 5. Okay? Nina, can you please stop the recording? Thank you. We'll take a 5 minutes break.